the compiler such by defining what's effectively a global preprocessor variable, and then subsequently always checking for it before you proceed to read the rest of the file. So this is just a long way of saying that Objective-C has made this better. So foundation slash, what's meant by the preceding word foundation slash? It's actually as simple as it looks. It's just a subdirectory, right? So somewhere on the system there is a foundation directory inside of which is a file called foundation.h. If you have a Mac or you're using the Lab Macs, most of these things tend to live in /system, /libraries, /frameworks. So you can actually poke around and see these files on your own or someone else's Mac. All right, so this, let's assume, is all the same as always, where you can take in command line arguments. Auto release pool we'll come back to later today and next week. This has to do with memory management. So if you never really liked malloc, you don't have to worry about malloc anymore because it's gone mostly. But although you will see that there's actually a lot of C code throughout the iOS SDK, especially for the lowest level, highest performing things like graphics, which still do make use of C. But for the most part, most things are in Objective-C. So we'll come back to what an auto release pool is in NSLog. You want to hazard a guess as to what this is used for? Printing, right? So this is similar in spirit to printf, but it's a little more versatile in that it's specifically meant to be used for logging purposes. NS stands for next step. So if you've read about Steve Jobs and his history with Next Step and the operating system that Apple acquired many years ago, they've maintained, Apple internally, this next step prefix, NS, in front of many, many of their constants and their class names because of the history of the language and the software development kit. So for now, NSLog you can think of as printf. The @ sign, what's this here? This is new. Yeah?
Saying interpret this as a string.
Exactly. Interpret this as a string. So in the world of iOS, there's actually two types of strings. There are the char stars from yesteryear that we've used in CS50 and 61 and the like, but there's also @ quote unquote, which are called NS strings. So capital N, capital S string. This is a proper object. So if you're familiar with Java from high school or the like, and you might recall that strings, whenever you double quote something, are automatically string objects. Same idea here, but so as to distinguish between char stars and string objects or NS string objects, you have to prefix quote unquote with the @ sign in Objective-C to say this is actually an object. And the upside of this is that even though it still looks like a string, we can in theory perform operations on it, methods on it, like getting its length or changing it to uppercase, changing it to lowercase on the object itself without having to pass it around all over the place like we might actually do in C. And then return 0 just means good. Nothing went wrong, but you can return almost an infinite number of other integers to signify some kind of error. So let's actually then do this in the context of Xcode rather than Vim. So I'm going to go ahead and fire up Xcode. And what you'll see from the get-go is that you'll typically get this screen at the start. And just to give you a quick tour through this so that you don't get lost when playing along at home, typically you're almost always going to click the Create New Xcode Project. However, if you do enable Git integration, which Xcode has, which can be useful, you can actually connect directly to a repository to grab your code, which can be useful for working with a buddy. And now let's click Create New Xcode Project. And here's where the fun begins, but also sometimes the potential confusion. Because we're using an IDE, and because we're using these templates that Apple provides, realize that on occasion there's going to be a lot of magic happening because whoever made the template wrote a little bit of code or tinkered around with the GUI and then saved the state of the GUI in such a way that you then don't have to figure out all of the various options to configure just to use that particular template. What do I mean by a template? Well, you might be familiar with this, a utility application in iOS or in Android. Let me go ahead and just call this demo. And we'll come back to the screen here in a moment. Let me just go ahead and quickly create a project to show you what I mean by a template. So when you say, give me a template, you then are opened up into the IDE, which at first glance is quite overwhelming. So let's ignore almost everything. In fact, let me turn off the right-hand side thing. Let me zoom in on the left-hand side. This is what we mean by a template. Xcode automatically gives you a whole bunch of files there on the top left. And we'll tease apart today and next week all of the various names and semantics of these files. But notice you're given a whole bunch of .h files and a whole bunch of .m files. This is useful because it's just incredibly tedious if you had to manually create all of these damn files just to create the simplest of Hello World applications. If you're familiar with the iPad, a very common paradigm in the iPad is what's called a split view controller, whereby if you the mail application. If you have an iPad, has your inbox on the left-hand side if you're holding the thing in landscape mode, and your emails on the right-hand side. And if you turn it, it automatically readjusts itself to the screen. This is the kind of built-in functionality you get for free because someone else wrote it in the form of these templates. So just realize that the templates tend to hide some magic. And even I last night, when I was trying to write a simple application from scratch, it was a pain in the neck using the latest version of the SDK because what I had taken for granted in the old version, I had to figure out what options someone else had clicked. So just don't get frustrated by these stupid things like I did last night. Just realize it's not really intellectually interesting. It's just a mechanical kind of thing. And Google is your friend. Stack Overflow in particular is quite a good reference for this sort of stuff. So let's start with a simpler one. Before we dive into an iOS application, let me go ahead and open up one of the prefabbed examples from today, which is just hello Objective-C. Actually, let me not do that. Let me pretend to do it from scratch. So let me go back to the template window. And I'm going to choose, instead of any of the things under iOS, for now, I'm going to choose something under macOS, only because I just want to do something at the command line with Objective-C, and I don't want all of the cruft that they would otherwise give me for an iPhone or iPad app. So I'm going to choose Command Line Tool. I'm going to click Next. I'm going to go ahead and call this Hello Objective-C. Notice these things here, company identifier. Often, this is just a domain name in reverse order. It can really be anything you want. But the idea here is that if you ship this code to actual devices or make it available through the App Store, you need some unique identifier. So a very common paradigm in the Java world, too, is what do you have that's unique? Well, probably your email address or at least your domain name that you own or your company owns. So this is just a convention in the world reversing domain names so that with low probability will some random person on the internet choose that same unique identifier for their app. So my bundle identifier is going to be edu.harvard.hello Objective-C. What language do I want to use? Well, unfortunately, Objective-C is not in the menu, but it is in fact there. So we obviously don't want C, we don't want C++, core data we'll talk about later in the semester, and core, foundation. So we saw this word before. The foundation classes are simply a whole bunch of things that you get with Objective-C through this SDK, things like NSString and a lot of the basics we're going to start taking for granted. It's sort of like the standard library of C, if you recall standard IO and standard lib. Use automatic reference counting. So this is the latest and greatest of features in Objective-C. And the class, frankly, is going to be a little easier now than it would have been had this course been offered last year. Because last year, up until summer at WWDC, there was no such thing as ARC, automatic reference counting. This is a good thing. So essentially, a year ago, you would have to do not only all of the mallocs for your code and all of the frees for your code, but also something called reference counting, where anytime you have a pointer in memory to some object, for each additional pointer that you want to have around, you would typically +1 that object's reference count. Languages like Scheme or Lisp actually do something similar for memory management, and we'll tease this apart. But for now, know that memory management in iOS has gotten a lot simpler, which is a good thing because it means you're less prone to errors. The downside, though, is that there's going to be a huge amount of material on the web, a huge number of books on shelves that still use the old version. So keywords that are now deprecated are keywords like retain and release and auto-release. So I mention this now again because the new books know about this change, but if you're just Googling around trying to teach yourself, realize you might run into old language versions that might otherwise confuse. So here we go. Hello Objective-C, edu.harvard, foundation, we'll use ARC. Next, it's just asking me where I'd like to save the files. If I were actually working with someone else, or if this was going to be more than Hello World, I would turn on a Git repository like that. So let me go ahead and create. And here's what I get in the way of a template for the simplest of command line apps. So let's do a quick tour of the user interface here without getting too stuck up on implementation details like this. So Xcode. Xcode, again, is what we're seeing and playing with in just a moment. You get this from the Mac App Store these days, which comes with Lion, and it's free if you have Lion. It's $99 if you don't, or if you have creative other ways, per the FAQs on the course's website. But here's a general tour of the interface for Xcode. Essentially, on the left-hand side, we're always going to see our files. And this is quite like Eclipse and NetBeans and Visual Studio and the like. In the middle, you're going to usually see your source code. A somewhat useful feature in Xcode, though, is you can see two panels of your source code for multiple reasons. Either one, to do diffs, so you can use version control built into the IDE and see what it looked like yesterday, what it looks like today. It can also be used for dragging and dropping things from one file to another, as we'll see, especially for user interface design. line. At the bottom of the screen here in green is the debug window. So rather than open a terminal, you actually have something like a terminal built in, and that's where you'll see your nslog messages. That's where you can use GDB or its newest counterpart at the command line there. And at the right-hand side is where Apple put everything that used to be in different places in the IDE, but they wanted to make it look simpler, so they put hundreds of features into the right-hand side, which you can simply close by default. So I do kind of mean this, right? They made Xcode look like this, which couldn't possibly look more friendly or more like iTunes. To run and compile your code, you click the play button, because they moved all of the complexity to the right-hand side. So honestly, as you acclimate to this environment, just like NetBeans or Eclipse, if you had a learning curve with those, when in doubt, hide things so it looks a little less scary, and then gradually unearth what you actually care about. So almost always, these little icons in the top right can help you navigate. Almost always, initially at least, just leave a couple of them selected. The default one on the left, and then the default one on the left here as well. And that will keep the screen fairly clear. So here, notice that my project, which I just started, haven't written any code yet, is selected by default, and I see all of this crazy stuff in the middle of the screen. So if you think back now to CS50 and 61, where you had make files, or you had environment variables, or you had a configure file, in C, there's many ways in which you can configure the compilation of a program. What Apple has done is essentially made almost all of those kinds of settings accessible within a GUI. So realize that all of the various drop-down menus and such you see here are fairly low-level details, like what compiler to use, what language to use, what version of iOS to support, and so forth. Those low-level details. And elsewhere, we'll see other low-level details like, do you want the application to still show the clock and the battery status, or do you want to hide that? You might otherwise do those in code, but you can also do them with this GUI environment. So in short, there's a whole lot of options, most of which probably you won't ever have to care about, but just do beware tinkering with those things, because I dare say if you try changing this knob and turning this thing and then forget what you did, it's very easy to break a project because there's so much going on behind the scenes. So look and save, but don't necessarily tinker unless you know what you're trying to do. So let's take a quick tour now of the files that await here. So underneath my project, there's a folder. There's this folder, there's this folder, there's this folder. Turns out these are not really folders. So these are groups. So there's an abstraction layer here whereby all of these things might very well be in the same folder on your file system, somewhere on your hard drive. But just for the sake of mental organization, you can create what look like folders but are technically groups that allow you to just hierarchically organize things. And what you'll find in different books and different versions of Xcode, Apple's own layout of code has changed a lot over time. In the past 2 years alone, this stuff keeps changing. So here too, if you're looking up other resources and you don't see a foo folder, just realize it might be because Apple changed their mind and kind of rejiggered things over recent years to just lay things out differently. So what's actually in here? So one, here is my main.m file, and that's where the only code of interest actually is. It starts with some boilerplate comments. It plugged in my name because it knows this is my computer. I could define a company name if I want or put anything else up there. I've got the import statement. I've got the function declaration, ns auto release pool, and that's it. Inside of there is nslog, quote unquote, hello world. So before we tease apart what else is in this file, let's go ahead and just run it, iTunes style, up here. Run. Notice that it build succeeded, and voila, at the very bottom right, you have some very esoteric output, but among which is quote-unquote hello world. And there's also stuff there. There's obviously the date and the time, and I forget what some of that is, the process ID perhaps, or something along those lines. It tells you how long it took. So this is the output of this program. Of course, for actual iOS and iPhone apps, we're going to have them popping up in a device or a simulator, but that's all it took to actually write this program. And in fact, let me go back to my mention of Clang. Let me just copy and paste this string. Let me now go into my desktop, into hello Objective-C, hello Objective-C, and here are three files, main.m, hello1.1, hello Objective-C.1, and then this PCH file. Here's main.m, the same file Apple gave me for free. Let me go ahead and run Clang with the flag of Objective-C with Arc enabled on a file called main.m using a dash framework of Foundation so that I can use the ns methods and the like. It went ahead and compiled. If I do ls again, notice I now have a.out, voila. So realize there's no magic with the IDE. It's just hiding some of the details with which you're probably familiar from this past fall or a couple of years back. All right, so let's just tease apart a couple of these files so that we can then move on to more interesting designs than hello world. This .1 file you can generally delete, at least for the things we're doing, because it's meant for a man page. If you recall typing man GCC or pulling up the man pages in a Linux environment, same idea. And because we said give me a command line application, I got some of this boilerplate, but I can go ahead and delete. Just beware when